Okay, we want to talk about the geometry of straight lines, right? The geometry of straight lines. So if you want to understand the geometry of straight lines, the first thing that you have to know about angles. And angles, these are two straight lines that meet. When two straight lines meet, they form a what? They form an angle. Let's say if this line meets with this line, right? If this line meets with this line, right, they form a what? An angle. So any line, right, if two lines meet, they form an angle. So we want to first discuss about angles. So the first angle that we want to discuss about is the acute angle. So an acute angle is greater than 0 degrees but less than 90 degrees. So we are saying an acute is greater than 0 degrees but less than what? 90 degrees. Right. And then the next set of angle is a right angle. A right angle. A right angle is an angle that is equal to 90 degrees. 90 degrees. So lines that are perpendicular, right, they form 90 degrees. They form a right angle. So that is the other angle that you are supposed to be familiar with. And then the third set of an angle is an obtuse angle. An obtuse angle. An angle which is greater than 90 degrees but less than 180 degrees. We call it an obtuse angle. Obtuse. So we've got an acute, right angle, obtuse. And then in geometry of straight lines, the next thing that let's now talk of a straight line. A straight line. So you can see a straight line is half a revolution. A straight line is half a revolution. Right. So half a revolution, we know that a revolution is 360. So half a revolution is equals to 180. So a straight line, all the angles that are on a straight line, they add up to what? 280 degrees. So there might be 2 angles, or there may be 3 angles, or there may be 4 angles. But these angles, if you add them up, they will give you what? 180 degrees. And we call these angles supplementary angles. So that's another fact that you have to know. And angles, if we add them and they give us 90 degrees, we call those angles complementary angles. So you have to know there is complementary angles and then there is supplementary angles. Right. We'll also revisit that fact again. And then number 5, the next set of point now, we want to talk of an angle which is now greater than what? 180 degrees. Right. So we call it a what? A reflex. Reflex angle. Right. A reflex angle is greater than 180 degrees but less than 360 degrees. We call it a what? A reflex angle. And then from there we talk of a revolution. A revolution is equal to 360 degrees. So from there now, you can be able to attempt as many questions as possible on geometry of straight lines. So maybe you can be given a question, maybe it's a line, and maybe you are given one angle. Let's say maybe that angle is 130 degrees, and then they say find x. So you know that angles on a straight line, they equal to what? 180 degrees. So it means x degrees plus 130 degrees is equals to 180 degrees. So for you to get x degrees, you now say 180 minus 130, and that is 50 degrees. So that's how you find this angle. So sometimes there can even be 3 angles. So if you are given maybe 2 angles, let's say maybe you've been given this angle, let's say it's 70 degrees and this one is 70 degrees, and then they now say find y. So you know y plus 70 degrees is equals to 180 degrees. So if you add 70 plus 70, you get 140 degrees. And if this 140 goes to the other side, it's going to change the sign. It becomes a negative. So your y is 40 degrees. Such that even if you add 70 degrees plus 70 degrees plus 40 degrees, you get 180 degrees. And you know that angles that are on a straight line, they add up to 180 degrees. So, and we call these angles complementary angles. So given like one point, if you want to get another point, use the theorem that angles on a straight line, they add up to 180 degrees. And then sometimes you can be given two angles, right? Maybe right on the right angle, right? And this other one we say maybe it's 60. And then they say find x. So you know that x plus 60 degrees is equals to 90. So if you want to find x, you now say 90 minus 60. We are solving an equation, or we subtract 60 minus 60, both sides of the what? Of the equation. So your x is going to be 30 degrees. So that's how you look for this other point. And then sometimes you can be given, now we want to talk about angles on a point. Angles on a point, they add up to 360 degrees. So there can be angles on a point. They can be like this, you see, or maybe there can be four right angles, this and this and this and this. So you know this is 90, 90, 90, 90. So they add up to 360. Or we can be given this ones, maybe this is 40, 70, right? 110, so it's 180. So they can say, look for this one. So you have to know that angles on a point, they add up to what? 360. So it's x plus 40 plus 1110 plus 70 is equals to 360. So you add these three values, 0 plus 0 plus 0 is 0. 7 plus 1 is 8 plus 4 is 12, carry 1, and then 1, 220. So it's x plus 220 is equals to 360. So we are saying 360 degrees minus 220, we get x. So we get 6 minus 2 is 4. So your x is equals to 140. So we are saying this point is 140 degrees. So we are saying all the angles that are on a point, they add up to what? 180 degrees. So if you get a question with any of the points that are on a point, you have to know that they add up to what? 160. 360 degrees. They give you what? A complete revolution. You see, it's a complete turn. This. Right. And the other important thing that we want to talk about, let's talk about vertically opposite angles. Vertically opposite angles. We get vertically opposite angles when two lines cross each other. So you know this angle and this angle, they are what? Equal. We are saying A and B. A is equals to B, or C, right, and D. So we are saying again, C is equals to D. This angle is equals to this angle because they are vertical opposite. A and B, they are equal because they are vertically opposite. Vertically opposite. And then C and D because they are vertically opposite. So vertically opposite angles, they are equal. So sometimes you get questions, right, with vertically opposite angles. You can get a question like this, you see, and it's a question like this one, right? You see this diagram, and you get an angle like this one, maybe it's 50 degrees, right? And then you have been given one point, maybe it's 20 degrees, and then they say find x, you see. So you know that, okay, x plus 20 degrees is equals to 50 degrees because this angle and this angle, they are what? They are vertically opposite. So if I want to look for x, it's now 50 degrees minus 20 degrees. So my x is 30 degrees. So this x is 30 degrees. So that's how you can find it. And then maybe you are given this point, maybe this angle. So since this is 20 plus 30, that's 50, right? 50, so definitely this point is supposed to be 130 because these are angles again on a straight line. We are saying 20 plus x plus this angle that we are saying 130 is equals to 180 because these are angles on a what? On a straight line. You see, these are angles on a straight line. Again, if you add these angles on a straight line, they give you 180. So if they say look for y, you know that y, you can say 180 degrees minus 50 degrees is what? You see that y is, these are angles on a what? On a straight line. So again, we are saying it's going to be 30 degrees. It's going to be 130 degrees. We are saying 180 degrees minus 50 degrees. So y is 130. Or we can just say y is equals to 130 degrees because it's vertically opposite. Right. And then from there, sometimes if you meet parallel lines like these ones, and there is a bisector like this one, you have to also know that this angle and this angle, right, they're equal. We call them Z angles, right? Z angles, or we can call them alternate angles, right? So we are saying Z angles or alternate angles. So we are saying A is equals to V, right? Or we can say C is equals to D. C is equals to D. It doesn't matter even like if the lines are like this, as long as the what? They are parallel. If there is a what? It means this angle A is equals to this angle B. This angle C is equals to this angle D, right? And this angle A and C, we call them co-interior angles, right? And then C and D, this C and D, this one and this one, they are what? Co-interior. And this co-interior, they equal to 180 degrees. Again, we've got what we call we've got also what we call F angles. If these ones are also bisectors, right, and they are bisecting like this one, we have to know that this angle again is equal to what? To this angle, right? Corresponding angles or F angles. Again, they are equal. So those are some of the terms that you have to know if you want to answer geometry. So given the point, maybe you have been given these two lines, they are what? They are parallel like this one, right? And you are given this point as what? As maybe it's, let's say it's 45 degrees. And then they say, you want the value of what? Of B. You have to know that B is equal to 45 degrees. And then if they say what is C? C is now 180 degrees minus what? Minus 45 degrees. And then you get 135 degrees. Right. So that's how you solve these involving alternate corresponding angles or Z angles or F angles or vertically opposite angles.